Hello everyone, I'm Rohan and I'll be going through SMO Senior 2018, question 8 to 13. So first let's look at question 8. So the general thought process you should have is that first we need to find P of X, and then since we know since we need to find the remainder when it is divided by X minus 4, we can sub in P of 4, and then that is the answer. And this is how we do it. So since we know that P of X can be divided by X squared plus 7X plus 1, we can write it as shown in the second line, where C is some constant. And once we expand it, we can compare coefficients and find out that C is negative 3. Then using this value of C, we can find out A, B, P of X, and subsequently we can find the answer. This is question 9. So firstly, I will label the following two angles H and I. Now, one important fact is that the sum of angles in a quadrilateral is 360 degrees. Using this, we can relate A, B, and C to I, and D, E, and F to H. And then to find G, we can use the angle sum in a triangle. And subsequently, we get this relation with G, H, and I. And then if you sum up these three equations, we get that the sum of A, B, all the way to G is 540. Next question, question 10. For this question, we should try and simplify the expression given, which is cosine 49 degree plus cosine 71 degree. We should try and simplify it as hard as we can until we get something of the form cosine x degree. And we note that 49 degree plus 71 degree is 120 degree, which is a pretty nice number in trigo. That's why we can let 49 degree goes to y, and then our expression becomes cosine y plus cosine 120 degree minus y. Using compound angle formula and subbing in the values of cosine 120 degree and sine 120 degrees, we can simplify this expression a bit. And then after this, we get something of the form a cosine y plus b sine y. So we can try to use our formula, and we get cosine negative 11 degrees, which is also the same as cosine 11 degrees. Hence, our answer is 11. Next, we have question 11. Now, this question is slightly harder, and what you have to do is you should look at the polynomials. So you can see it's of the form something x plus something xy plus something y squared for both of the polynomials. And also you have to focus on the coefficients and see if you can relate the two polynomials to form an inequality. And this is what we shall do. To make things tidier, we let a equals to 25x squared minus 20xy plus 40y squared, which is 36, and b is equals to 22x squared minus 3xy minus 2y squared. And now we should try to get a minus some constant times b is equals to a square polynomial. And once we get a square polynomial, we can use the fact that all square numbers are always positive or 0. And after some trial and error, we notice that k can be 12. And using a minus 12b, we can simplify to x plus 8y whole square. And this is greater than or equals to 0. Hence, we get 36 minus 12b is greater than or equals to 0. And then we can find that b is greater than or equals to 3. Now, for SMO round 1, you can probably just leave your answer at 3 at this point. But one important thing we should still do at this point is to show that the equality can indeed hold. After trial and error, we can find that the equality can hold, and hence the answer is 3. 3 is indeed the minimum value of b. Next up, we have question 12. Now, this question is similar to one of the previous trigo questions because we are looking at 108 times sine to the power 6x plus cosine to the power 6x. We should try and simplify this. But before that, to stop writing sine x and cosine x a lot, we can let a equals to sine x and b is equals to cosine x. And we know that sine 2 of x, which is 2 sine x cosine x, is equals to 2ab, and this is 7 over 9. And from the identity sine square x plus cosine square x is 1, we have a squared plus b squared equals to 1. Now, we notice that a to the power 6 plus b to the power 6 is actually the sum of a squared cubed plus b squared cubed. Then we can factorize this. After factorizing this, we can use the fact that a squared plus b squared is 1 and then get rid of that. And now we're left with a to the power 4 minus a squared b squared plus b to the power 4, which should look like a to the power 4 minus 2a squared b squared plus b to the power 4. And you can make it like that. Now after applying some algebraic identities and then subsequently subbing in the values that we have, we get that the a to the power 6 plus b to the power 6 is 59 over 108. Hence 108 times this is 59, which is our answer. Then we have question 13, which also the thought process should be that we should try to simplify the equation. Now you notice that you have a log base 2, log base 16, things like that. And 16 is 2 to the power 4. So one thing we can try to do is try to show that log base a to the power b of c is in fact 1 over b log base a times of c. Using this result, we can simplify our equation a bit, and we notice that log base 2 of x appears more than once. So we can let u equals to that. Then you get a quadratic which you can solve. And the first value of u we have is 7 over 3, which will not give you an integer value of x. But our second value, which is 1, will give you that x equals to 4. Then that is our answer.